All right, so let's apply what we learned about radians and about special angles to the whole unit circle. So here is quadrant 1, where I've labeled 0 degrees, 30, 45, 60, and 90 degrees. And we talked in the last lesson about converting these to radians. So I'm going to write the angle in radians in green next to my degree measurements. Pi over 4, pi over 3. Something's not right about this. No, this is right. Okay. And pi over 2, because 180 would be, actually let's label that one. 180 would be halfway around the circle. Which is also pi. And then for the sake of completeness, let's go the rest of the way. So 0, 90, 180, plus another 90 degrees is 270. And in radians, that is 3/4 of the way to 2 pi, or pi plus another half of pi. So that's going to be 3 pi over 2. And then if we take one full lap of the circle, that would get us to 360 degrees, or 2 pi radians. Remember, a radian is a size of angle, an amount of angle, where the amount of arc, the length of the arc, is equal to the radius. So it's a nice big chunk of a pie, and there are 2 pi radians in an entire circle. So if you were to measure this radius, it's 1. The circumference of this circle is 2 pi times that radius, so the circumference of the circle is 6.28, or the angle in the circle is 2 pi radians. Okay, it might seem weird that this point is labeled with 2 different angles. It's labeled with 0 degrees, or 0 radians, and it's also labeled with 360 degrees, or 2 pi radians. And that is actually something that you could do for any of the angles in a circle. An angle describes, if you start at the positive x-axis and you walk counterclockwise, how far do you need to go to get to a certain point? So for this point, we could just stay right there and not move at all. Or we could also arrive at this point by taking one entire lap of the circle. And actually, we could arrive at this point in a bunch of ways. We could not move at all. We could take one entire lap of the circle. We could take even more than one lap. We could take 2 entire laps. That would be 720 degrees. That would also be an angle that refers to this point. Or we could even go the opposite direction. And if we go the opposite direction, we call that a negative angle. So for another example, if we were talking about this point, let's think about 2 different ways we could describe the angle needed to get to this point on the unit circle. One way would be to start here at the positive x-axis and go 45 degrees in this direction, which would be negative 45 degrees. Or if we were only going to go in the positive direction, we could start here. We could go 90, 180, 270, and then 45 degrees more after that. So that would be 270 plus 45 degrees, or 360 minus 45 degrees. Either way you think of it, that is plus 45, 315 degrees. So when we label the points, we generally label them with the angle that would get you to this point that is between 0 and 360 degrees, meaning if you were to start at the positive x-axis and go counterclockwise and stop the first time that you reach that point, that would be the amount of angle that you walked. But you could also get to this point by going negative 45. Let's think about what this angle would be in radians. Actually, let me write this negative 45. So if we were going to write this negative 45 in radians, it would be negative pi over 4. Or we've got pi plus a 90-degree chunk is a pi over 2. That's 3 pi over 2. Plus another pi over 4. So if we want to label this in radians, we will add this 3 halves with the 1/4. And we get 7 over 4. So the 3 halves refers to the 270 degrees. And then 1/4 more is the last 45 degrees here. So this ends up being, in radians, 7 pi over 4. Okay. So anytime you're trying to figure out what would the radians be of an angle outside of quadrant 1, you can add however many sections of 90 degrees, each of those are pi over 2, and then you could add whatever number of degrees is left. So try to figure out what this angle would be, the angle of this point would be, in degrees and in radians. In degrees, it's not too bad. I have 180 and then 30 degrees more. So that is 210 degrees. And then if I want to convert this to radians, I can use the conversion fraction, or I can just figure it out in the sense that I have pi plus pi over 6 more. So that's going to be 7 pi over 6. 1 whole pi plus another 1/6 of a pi. If you can combine those fractions, you will get 7 pi over 6. Okay. So let's talk about how you could find the sine and cosine of an angle using the unit circle. So the first example I'm going to do is ask, what is the cosine of 150 degrees? So I need to figure out, and you could get a question like this without having this picture in front of you, but you could sort of draw it yourself. So I would think of 150 degrees as being 180 minus 30. So we're going to 180 and then we're going 30 backwards. That's going to take me to 150. Now I know this is kind of the flat skinny triangle, and it's asking me for the cosine, meaning this bottom side here. So this is the 150 degrees. Now I want to figure out the cosine of this angle. Remember, the 150 degrees is measured from the positive x-axis. So this angle is 150, but I can still draw this triangle using the reference angle of 30 degrees. And I know that for 30 degrees, this side, this longer side, is the square root of 3 over 2. But because I can tell that I'm going in the negative x direction here, this should be a negative sign. So I'm kind of using the unit circle as a picture in combination with knowing my special right triangles to figure out, okay, when I have this 30, 60, 90, this longer non-hypotenuse side is square root 3 over 2, and then I can tell that I should be negative because I'm here on the negative x side. Okay, so why don't I label this point with its x and y coordinate? The x coordinate is the cosine, which is square root of 3 over 2. And the y coordinate is the sine, which the question didn't ask for, but I can write it anyway. 1/2. Oh, and this should be a negative x coordinate, but a positive y coordinate, because I'm here on the negative x coordinate side, but still the positive y coordinate side. Okay. Now let's try an example in radians. So let's say we were asked to find the sine of negative pi over 4. Okay. This has a couple things going on. First of all, we have a negative angle, which tells me I'm starting from the positive side. I'm going to go this way instead of this way. And my number is in radians, so it might be a little bit harder to see where it goes. But pi over 4 goes with 45 degrees. So if I'm doing negative pi over 4, I'm going to go right here to negative 45 degrees, or 315 degrees. So I want to figure out what the sine of this angle is. I could think about the angle as being negative pi over 4, or I could start from the positive x-axis and go clockwise, and it would be positive 7 pi over 4, or positive 315 degrees. Either way, the sine and cosine of this angle are the coordinates of this point. And if I think about my reference triangle, I can see that it has angles of 45, 45, and 90, which means that both of these sides have a length that is the square root of 2 over 2. So my cosine, my x-coordinate, is going to be something related to the square root of 2 over 2. And my sine, my y-coordinate, is also going to be something related to the square root of 2 over 2. And then I can use the unit circle to figure out what the positive or negative sign should be. I can tell that because I'm over here, I should have a positive x coordinate and a negative y coordinate. So I'm going to put a negative sign in front of this. So the sign of negative pi over 4, I went to that angle on the unit circle, and then the sign is asking for the y coordinate. So this is going to be equal to negative square root 2 over 2. Okay. These are the same answers that you would get by typing these things into a calculator. In degree mode for this one, and in radian mode for this one. Let's do one more example, and this one is going to be kind of backwards. We want to find an angle let's say theta, where sine of theta equals negative square root of 3 over 2. Okay. So I have a few options here. It seems like this might be enough information to tell me what the angle is if I know the sign of it, but that's not quite the case. This square root 3 over 2 is the length of the longer side of the 30, 60, 90. And the sign is the y coordinate. So I'm going to look for triangles where the y coordinate is this number. And it turns out that this point and this point both fit that condition. They both have a y coordinate. You can see that they have the same y coordinate. They're on the same horizontal line. And they both would have a y coordinate of negative square root 3 over 2. So let's figure out what these angles are. This one, you could think about it as 180 plus 60, or 270 minus 30. This is 240 degrees. And this one is 270 plus 30, 300 degrees. The coordinates of this point are, here's my reference triangle. I've got the short side here. That's 1/2. And my x coordinate should be negative. So it's negative 1/2. And my y coordinate is the one that I was asked for. Negative square root of 3 over 2. The vertical coordinate here is this longer side of the 30, 60, 90. So it's square root 3 over 2, and it's down, so it's negative. The coordinates of this point, the 300 degree point, are almost the same. 1/2 negative square root 3 over 2. This is a positive 1/2 here because I'm in the positive x direction. Okay. We can also figure out what these angles would be in radians. I could do 3 pi over 2 minus pi over 6, or I think it's easier to think about pi plus another 60 degrees is plus pi over 3. So this would be 4 pi over 3. And this one, 3 pi over 2 plus another pi over 6 is, let's see, 3 pi over 2 would be 9 pi over 6. 10 pi over 6, simplify that. 5 pi over 3. Yeah, that seems right. Okay. So I have these two angles, and they both have a sign of negative square root of 3 over 2. I have 240 degrees. I have 300 degrees. And I could even do something else. I could even do, starting this way, go this direction. I can get to this point. And that would be negative 60 degrees. I could start at this point and go all the way over here. That would be negative 120 degrees. So if you know just the sign of an angle, that can narrow it down for you, but it won't necessarily tell you exactly what that angle is. You would need a little more information. Something like the angle needs to be between 0 and 360 degrees. Then that would mean that we couldn't have these two. If they told you the angle, the terminal side of the angle is in quadrant 4, that would be 1, 2, 3, 4, this one. Okay. So I get that this is a lot of information. It's probably not that easy to learn on your own. I'll be available to answer questions and stuff. We will get a lot more practice with recognizing coordinates of certain points on the unit circle and converting to radians and how those coordinates relate to sine and cosine.